Hello and welcome to the Basement Podcast. I'm Daniil.
And I'm Alexander.
You're also called Xander.
Yeah.
Um, and oopsies, I just hit the microphone. That's bad. Um, Today we're talking about wormholes and white holes and black holes and all of the holes that come with
They kind of all
space
have to
time.
do with each other.
We're mostly talking about space time and uh, the theories that go along with it. So first things first. Let's go over what a wormhole theoretically and what all science fiction novels paint it to be as. They paint it to be as this like magical just bridge, which they're called in science Einstein-Rosen bridges, because that's a solution to Einstein's equations. But the thing is about wormholes, if they did exist in nature, which I doubt they do, or not in nature, just in space and time, really. They're very, very, very small. Um, and the amount of energy needed to escape that gravity inside um, that wormhole, and first of all, getting it open and keeping it open is so great that you would cause an imbalance in the positive and negative energy in the space time and universe and the continuum of space time. So like that can't really happen. And we were talking earlier, and we were trying to figure out what happens when you borrow too much um, negative energy, which it does exist in nature. It's just very, very, very small and doesn't really do anything. And I'm just maybe Xander can help on this, but what I'm thinking is anti energy, anti gravity, negative energy, whatever you want to call it, is like antimatter. And
Yeah, it's like if you have matter and antimatter, right?
yes,
So the theory is that if you somehow could get antimatter harnessed, if it came in contact with matter, it would just
boom, cancel
obliterate.
out. Yeah,
Boom. So, but apparently, I'm not completely sure on this, but that's not exactly what happens with um the dark, not dark, but the negative energy. It's not the same thing. If it comes in contact, apparently, with normal energy, it doesn't blow up. But it the they I don't remember. Is the antimatter supposed to maybe occur in nature, or is that
it
completely
does. It
artificial
does.
too?
It's very, very, very rare. It does occur in nature, and it's a product of the Big Bang. Um, it again, it does occur in nature, but it's very, very rare, very, very expensive, because of the fact that if it comes into contact with matter, there's a big boom. And not necessarily, it doesn't exist in nature, it exists in the vacuum of space. And it can be created, but I believe it's the most expensive thing on Earth to create. And, like, to have an actual amount that you could, I don't know how to explain measurable amount. It's a large chunk, not just like 2 or 3 atoms of it, or 100 atoms of it. It's expensive like nothing else. It's really expensive. So yeah, um, but antimatter does occur in nature.
Okay, so if antimatter occurs in nature, then probably negative energy would probably occur in nature too.
Yes, but
Maybe as another byproduct of the Big Bang.
it's very, very small. It's even smaller than
Yeah.
the amount of antimatter there is. So it's harder to and the thing is, it doesn't exist for very long. It's an anomaly. just like what antimatter is. It's an anomaly that, it's not technically supposed to happen, so doing with stuff with it is very hard.
Yeah,
Um,
but we haven't even talked about what it's supposed to be used for. This all ties back into wormholes.
uh,
Um,
you go. You can
yeah,
talk.
the idea is that so wormholes are extraordinarily small if they do exist. Like I don't even know how
Smaller
small.
than an
Very,
atom.
very small. You
Probably
couldn't
like
fit hardly anything through it.
yeah, problem smaller than an atom, I think.
Yeah, they're extremely small. And the reason for this is because gravity is literally just crushing them. Because the wormhole is like a rip in time space. It's not really supposed to be there. And space time is. Did I say time space?
Time
I
space,
meant
yeah.
space time. But it's supposed to be. It's not supposed to be there. So, universe kind of like trying to fix itself and get rid of it, and gravity is just crushing it
It's
and
basically a
pulling it
singularity.
in.
It turns into a singularity almost.
Yeah, it just goes poof, doesn't exist anymore.
Yeah,
It never was supposed to exist, really.
yeah, in the first place.
Yeah, but there is an idea as to how we could actually expand them and keep them open. That's where negative energy comes from. Negative energy is supposed to repel gravity. So if you can get like somehow negative energy inside of wormhole, it could actually help the wormhole to expand to a size that you could actually fit stuff through. And what happens after that is kind of unknown. I
Because it's
mean,
never
the
happened in
theory is
nature.
that it goes to other places, as you probably have heard
Other
of in
places and other
any
times,
sci-fi
actually.
movie ever.
Yeah, other places
Um,
and at other times, actually.
yeah,
Yeah. But see, the problem with negative energy is, for one, very hard to come by. For two, it only exists for a very short period of time. So, building it up is, from what I understand, pretty much impossible.
yeah.
So you
At
can't.
least as of now, it's impossible. We
Yeah,
don't have any way of doing that
yeah.
at all. Um, but it also is that something like the universe only allows you to have so much of it. So you can think about it like this: you're getting a loan out of the bank, right? But you're kind of in debt
Yeah. This is
because of that loan. Yeah, they're
this
only
is
going to let
a
you take so much out
yeah.
because of that.
This is a thing we saw in a video we both watched actually. Yeah, using that bank analogy. You know, it's like I want to kind of use the US government here. You have a debt and then they raise the debt ceiling. But in this situation, you can't raise the debt ceiling.
Yeah,
You,
you're
you,
stuck
you get
there.
to a certain point, which is not very much at all, and you're stuck there. You
And
can't.
here's the thing about the universe: it kind of just like takes its debt back almost immediately.
Yeah. It's just like,
Just done. You don't get you can get extremely small amounts of negative energy, and it's not there for very long at all.
and this, and then you look at a black hole, um, and like you see, okay, what if we use a black hole somehow to time travel? But you have this gravitational pull that wouldn't allow anything to escape from it, and you know, using a black hole to time travel really isn't very, because we don't know. We have no idea how big they are. We know they're big, but we don't know how quote unquote deep they are. I know because if you think about it, a black hole is just it's uh, a circle of mass or matter around a singularity. It's getting denser and denser and denser, um, and so that you wouldn't be able to escape it. There's no way you go in, you can't come out. Um,
Yeah.
and
So,
the other thing that we were talking about earlier was white holes. So we had a little bit of a dispute, that Xander thinks that it's on the other side of um, of a black hole. But I looked it up and I did some research, and actually, and think about it this way: we've never actually seen a black hole or a wormhole, for that matter, and we already talked about that. But we haven't seen a black hole or a wormhole, and so what science depicts it as, yes, is very educated guess and very possibly true, but we don't actually know that. And from what science has gathered, a white hole and a black hole look very similar from afar. Because there's nothing around them, because everything is either sucked in or pushed out. So you can't really tell a difference between the two. And so that's something, and we don't. Although Xander, you can actually talk about this because you've talked about it before, but uh, there have been um, discoveries that point to the existence of a black hole, white hole, and scientists think they have it. But Xander, you can go on with this because you talked about it before, but I don't exactly know what happened after that. But you said,
So you mean the gamma ray thing?
yeah, the gamma ray thing, yeah.
Oh yeah. So I don't remember exactly when it was. Sometime like what was it? I want to say it was 2013, but don't quote me on that. But there was a gamma ray explosion, and it's usually caused by a star going nova, right? Gamma ray is the most
Yeah.
powerful type of wave in the universe. Very big explosion. Only there was one problem. There was no star there to cause the explosion.
Yeah.
So the debate is what did cause the explosion? And why did it happen? One of the theories was that it was a white hole. Because I think it was like the repelling the energy, right? So you
Yeah.
talked about how white holes repel energy, right? So, but the problem with that is there was no energy there in the first place. So the other theory is that it actually just came out of the white hole, and that's where I get the idea for the white hole being on the other side of a black hole, right? So it's strange to think about. But
It's theoretical
so the
physics. What do you
black hole
expect?
is a singularity that's pulling everything in, never ever lets anything out. Um, so what happens to all that matter? Where does it go?
It turns into a singularity, and then I honestly, and
But according to a whole bunch of laws, you can't destroy matter or energy.
but Hawking radiation, how does that work? Pull in, because Hawking, again, is a solution to Einstein's equations that says black holes can evaporate. If you look,
Evaporate. So
but I
so
don't know where.
apparently it just like poof goes away.
Yeah, but that's what I'm. I don't exactly know what happens to matter there.
That just doesn't seem right. That
Yeah,
like
what I just
now do you have to remember that the universe is constantly screwing with all of our theories of how physics works and stuff. But I mean, hey, maybe this is a case where matter can be destroyed, and if so, that's a little bit. That's actually kind of scary if you think about it. So you got all these black holes running around in the universe, right? They're just basically eating it up. So basically, eventually, the universe is going to be eaten entirely by black holes. That
event.
just doesn't seem right to me. That's a little strange. So so my idea was that the white hole is on the other side of a black hole, right? And there's also the theory that there's like but I don't know. They don't call them sub universes, but like I don't remember. They're like not alternate, but like sub universe or something like that.
Yeah,
Um, like a universe that's like on a different plane than ours. So
different
the idea
dimension,
is that
different
the white
dimension,
holes open up in different planes, spit
dimensions.
everything out that the black hole consumed once the black hole dies.
Yeah. So looking it up here, um, black holes Um, hold on, I'm confused. Okay, black holes um emit. That's what Hawking radiation is. That black holes emit black body radiation, which I don't exactly know what it is. I'm looking at it now, but they emit radiation, and it's that's somehow how they evaporate. But back to um, wormholes, uh, we kind of went on a tangent with the white holes, but I had a thought. Like, you see, in all depictions in science fiction in anything, it's always there's always this curve, and then there's a hole going through it.
Yeah.
So does that?
Well, according to Stephen Hawking, there is no event horizon. That's what that thing is that you see.
Yeah, that
Um, I don't remember exactly why he says that. I mean, the event horizon's like stuff going into the black hole. It seems
yeah.
like so. Light's
It's like
trying to escape it, right?
it's the
Failing miserably. That's what's being pulled in. That's what you're seeing, basically. But
it's
he
the
says that's not true. That doesn't actually exist around the black hole.
it's basically the event horizon for people who don't know, which you probably would, but I'm just gonna say it anyway. Uh, is the point where when something gets into that point, there's no getting out.
Yeah. So you can actually think of it like a black hole actually reminds me of like a negative Saturn. So you have Saturn, right? It's the planet. That's the black hole. Think about it like that. The
Right?
rings around Saturn are the event horizon.
Yeah,
If
and
you get
that's
stuck within um the area of those rings, you're screwed. There's no escaping that. Nothing can escape that.
yeah. Um, but going back to what I was saying about the wormholes earlier, just before you went on this tangent, I I'm kind of confused as to why wormholes are depicted as they are, because if the way that it's shown, that means that wormholes are worm the universe is just a huge circular or spherical thing, because how how does the universe just fold? If it's on the same plane, then you can't go, like, if it's on an XY plane, you go from one end to the other, but how does that happen exactly? Because how does the wormhole cut through that space?
That's what we really have no idea
Yeah, and
about.
that's what I'm kind of thinking. Like,
It's like, think about it like this. I actually saw this in a video. It's a really good way to understand it. You got an apple, right? You got a worm.
yeah,
The worm, the apple,
that's
the
why they're
outside, the
called
skin.
wormholes. Yeah, that's why they're called
The,
wormholes.
yeah, the
So,
wormhole. That's also why they're called wormholes. But the apple is the skin's the our visible universe, right?
yeah.
The worm can bore through that
Oh,
and
right.
just go
Yeah, I
through and come
forgot
out the
about
other
it.
side.
Another dimension, somehow.
Yeah,
Another dimension that you go into.
but that begs the question: does that mean you have to travel through that dimension in just that, like in its time frame? Like, okay, so you're trying to go to, I don't know, Mars, right?
Yeah.
And but you want to get there really fast, so you try to go through a wormhole. What if by going through the wormhole, you still just have to go the same distance in a different universe?
Yeah,
What if it's just a bridge in our universe, but it's the same distance in another?
but if you think about it, like, I'm sorry, I'm a nerd, but think about Minecraft.
Hmm.
In the Nether, um, you have a displacement of, like, space, because you go one block in the Nether, you go 8 blocks in the overworld. So maybe that is somehow tied into that, where in one dimension this
So it's
this
like an alternate dimension that like it makes everything shorter,
yeah,
something
and
like that.
maybe
Yeah.
like there's no gravity, so if you get launched into it at a good speed, hyperspace, quote unquote, you go through it and it doesn't seem like that long because you're in a different universe where that um, that doesn't necessarily or the space that you travel isn't as large, so it doesn't pose as much of a problem to go that distance. But again, how is the just you know how
Well, first of all, we haven't even really mm, technically proved that alternate universes exist. We have some pretty good theories about it,
yeah
but once again, never seen it. So
yeah and just so confusing because you know if you have that idea of you have a different dimension, then it would work if you use the multiverse theory.
yeah.
The multiverse theory is just there's an infinite number of possibilities, an infinite number of universes. Maybe in one of those dimensions, one of those universes, the place you're trying to go is somehow right next to or closer to where you want to go in this dimension.
So like an overlapping universes.
Yeah,
That kind of makes sense. I can see that.
because
So basically, um, you got it's hard to explain.
it is really
It's easier to like visualize. So you can think about it sort of like this. You have a like a piece of paper, right?
yeah, and
You
you
want to get
just
to one point, from one point to another, really fast, right?
say
You
from
don't want to
corner to
take much time,
corner, corner
but
to
the
corner.
points are really far apart. What if you took the paper and folded it so that the points were just right next to each other? That's what a wormhole is.
Yeah, but then how
But
does
that folded part is the alternate path that you took
yeah
to get
that
there.
little space in between that you create is the path that you took. What if the whole concept of wormholes, because you just came to my attention, where by folding over this theoretical piece of paper, there's no distance between the points, and that's how you get there so fast.
Yeah, like you just go in the wormhole and then boom, you're there.
Yeah.
Once again, how?
Yeah. Fun. That's true. I'll include some pictures in the post processed video of like the kind of wormholes we're talking about. And I'm just trying to think like how is the first of all the gravitational force avoided. Second of all, the amount of contorting you'd have to do with the space-time continuum. And third of all, my next kind of lead on is wormholes are somehow take you to a different time. So what if you just travel the same distance? You're just not aware of it because you're in a different you're taken to a different time.
So basically,
You
you're
do it,
accelerating time, basically.
yeah, you do it, but like you just don't you say you just I'm trying to think of another reference in The Flash, which is a TV show. That's a great show if you want to watch it. That kind of deals with this stuff sometimes. Um, when the Flash, who's the main character, goes into a wormhole and then um, and goes into the future and then comes back, he comes to the exact moment that he left. So to the other people in the universe and the other people in the worlds, they don't notice the difference. So they're like, "Did it work?" And yeah, if he's been there for 10 years, he's been there for 10 years, but he hasn't been gone for an instant for them. So what if that's what happens, that you've traveled through that time, but to the onlooker's eye, so to speak, you don't you don't travel. It doesn't take long at all to travel.
Yeah.
So what if I'm trying to think how to word this. What if the time and distance you travel is no different? Just the wormhole kind of takes it and puts it on pause. Kind of. Sure, we can look at it that way. Or what if somehow? No, that wouldn't work. It's just confusing, really.
But the wormholes don't really. They say wormholes have nothing to do with time, really.
No,
It's all to do with the space plane.
I thought it was also time, because time and space are intertwined.
Yeah, it's like a is it's the bridge thing is has to do with the space part though. But I guess your theory is that it takes the same amount of time to get there, but it's
Since
shorter. It's not.
no, no,
mm,
I'm just trying to think. In the wormhole, I guess you could look at it this way. In the wormhole, time still passes, but outside the wormhole, there's nothing. Uh, there's nothing going on. So you technically, to everybody else, are there in an instant, but for you, you've still been in that time. So the wormhole, first of all, it's an anomaly. So then it just doesn't really follow the laws of space time very well. And so I guess what you could think of it as would be just a place where um, time and space aren't affected. Kind of like a. Have you seen the movie Doctor Strange?
Yes.
Remember and I'll explain this to you. Remember the part where um, they go into the mirror world,
Uh huh.
where nothing happens, but they can still train and they can still learn in that. And this is, if you don't know what Doctor Strange is, it's a person who got into a car crash, and
If you don't know what Doctor Strange is, go watch the movie. It's good.
it's a good movie, yeah. He got into a car crash. He was a neurosurgeon. His hands got screwed up, and he's been told about this place that can use kind of like it does use magic to heal him. But he realizes that he doesn't. He wants to serve a greater purpose than just being a neurosurgeon. So he goes. He learns this magic. But the way they train in this movie is that there's this mirror world that is exactly like the real world, but nothing is changed in the real world that happens in the mirror world. So what if that kind of scenario happens when you open a wormhole, where this wormhole is a place and time where those both exact concepts do not exist?
Hmm.
Does that make sense to you?
Yeah.
Although it's kind of mind-boggling, it doesn't make really much sense.
I think a better way to look at it is like, well, so you go in the wormhole, right? If you when you come out the other side, is it going to be the amount of time it would take you otherwise to get there? Or well, actually, the amount of time it would take you otherwise to get there is it varies though because
you
You could
could
go
be
light speed, or you could be going at the speed of a snail. So
and you could be going to different places. It doesn't necessarily. You could be going to, I don't know, like you could be going to your friend's house who lives an hour away, or you could be going to the other side of the space time continuum. So, yeah, that kind of also poses an issue.
yeah, like how far are you going? How fast are you going? That.
Yeah.
Mm,
But since again this has never happened, there's no way of knowing. Which is infuriating because it's so cool.
yeah. All right. So we covered wormholes pretty much. We covered black holes. You want to say anything else about white holes or?
Is there I don't think there's much else to talk about there because
All of this is pretty much theoretical, except the black holes, which we have fairly solid evidence that they exist in the way we think they do.
yeah, yeah. The I'm thinking cuz white holes would be very hard to study. And so would black holes actually. Cuz white holes it's impossible to get up close to. Black holes, you go too close, you're dead.
Yeah, pretty much. You can't really observe them. Well, for one thing, you can't observe the well, you can't really see the black hole because it's a black hole. The only way you could know where it was is if you saw like an absence of stars in what we think is a sphere
But see,
shape.
that's the other thing with a white hole. It looks the exact same because there's an absence of stars.
Yep. So
Abs-
basic. But herein lies the problem. You don't know which one's which. If they both look the same because one sucks in light, one repels light.
yeah.
Hmm. What if then how do you know which one's which?
And then there's a bigger problem. How the heck do you see it if there's no light at all?
Yeah. Like you shine a light on it, it's just gonna bounce right. I mean, you could, I guess, if you shine a light at a white hole, right? You're just gonna reflect right back at you. It's gonna work. Yeah, actually, you can probably think of it kind of like a mirror.
Yeah.
It'll just bounce right back
It,
at you. You
yeah.
won't really be illuminating it at all. So I guess, and if you don't see anything bounce back at you, then it's a black hole.
Yeah. But if you're that close, you're dead.
No, but you could use radio waves.
Oh, you
So,
could,
like,
yeah.
radio waves travel forever, I think.
Yeah.
And so shoot a radio wave at this absence of space, and if it doesn't bounce back, it's a black hole. If it does bounce back, probably very fast it'll bounce back. It's a white hole.
Yeah.
But never witnessed a white hole.
I
So
never really witnessed a black hole either, so should I copy game theory and say that's just a theory, but not really, because that would be copyright infringement, but it wouldn't really be copyright. I don't know what to do. Anyway, I think we covered, or sucked the meat out of all this topic that we can. I think our next podcast is going to be on, let me look at my list. Our
the
next
list
podcast,
out.
yeah. Anyway, so I think the next podcast will be on either space-time relationship, which we also kind of covered here, or atomic bombs and atomic physics, which I kind of thought of because we read this year at school. We read a book called Bomb, which was a very interesting read about the development.
Are you sure we didn't already do atomic bombs?
We know what we did. I think was no, we did black holes. We didn't do atomic bombs. I don't think.
Okay.
I can check, but I don't think we did atomic bombs. If we did, then scratch that. We'll probably do something on World War II. Yeah. Thank you for watching. I hope you enjoyed, and we'll see you in the next one. Bye.
Bye.